Algebra 2, Lesson 50, finding inverses of relations and functions. What I want you to understand is that inverse, like even if we're, inverse doesn't mean perpendicular, right? We can find inverse functions or even inverses of linear equations, but inverse doesn't mean perpendicular. So if we went to graph them, they're not necessarily going to be meeting at 90 degrees. It's not just it's not the opposite reciprocal slope, okay? So if you're looking at a visual form of it, don't assume that, because that would be an easy thing to assume that if something is inverted, that it's just the exact opposite of it. All right, so a relation is a set of ordered pairs, right? We can look at a set of data where we have xy, 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 and we can order those according to the domain and the range, correct? Okay, so a relation is a set of ordered pairs. If R represents a relation, then the inverse relation is the set of ordered pairs obtained by reversing the coordinates in each pair of that relation, or R. So if AB is in a relation, then the inverse of that is BA. So it's really easy if we're looking at a set of coordinate pairs, right? So if I gave you, somebody give me some coordinate pairs. 2, 6. Give me another one. 3, 3, 6. 3, 7. Okay. 1, 1. All right, good. That's a good set of coordinate pairs. If I wanted to know what the inverse of these were, can anybody tell me what the inverse of those coordinate pairs would be? 6, 2, 7, 3, 1, 1. Sure. Those are that's the coordinates of the inverse relation. So the inverse of a relation may or may not be a function. Okay, if a relation and its inverse are both functions, they're what we call inverse functions. But until we know that they're functions, they're just inverse relations. Do you follow me? Okay. Now, looking at the domains, the 2, the 3, and the 1, they're all different, right? So is 2, 6, 3, 7, and 1, 1, is that a function? Would that represent a function if I graphed them and connected the points? Yeah. All right, let's look at the inverse relation. 6, 2, 7, 3, 1, 1. Could those represent a function? Yeah. So these are what we would call inverse functions of each other. Okay? So if a relation is given by an equation, we follow 2 rules. One, we interchange the variables, and we find the equation for the inverse. Basically, well, we'll see here in a second. I'll show you. But let's, I'll go ahead and hit on it. Let's write an equation in slope-intercept form. Let's say y equals what, x? Give me a number. 5x plus or minus. What do you want? Plus or minus? Minus. Give me another number. 3. All right, so let's say we had the function y equals 5x minus 3, and I wanted to find the inverse of this. So rule number 1 is that I switch the variables. All right? Now, the coefficient doesn't go with the variable. The coefficient stays exactly where it is. So if I was going to rewrite this with rule number 1 being swap the variables, what would I now write? X equals 5y minus 3. Now, what I need to do is solve for y. Okay, so rule number 1 is reverse or swap the variables. Rule number 2 is solve for y. Okay, so how do I solve for y here? Add 3 to both sides, good. All right, so as I'm writing that, I get x plus 3 equals 5y. Now what? Divide by 5 on both sides. So I divide the whole side by 5, or do I just divide part of it by 5? Whole side by 5. All right, so as I rewrite this, the equation becomes y equals what? 1/5 x plus 3/5. This is the inverse of this. Okay? And you'll notice that 5 and 1/5 are not opposite reciprocals of each other. They are, in this case, reciprocals, but they're not opposite reciprocals. Right? They both have positive slopes. Does that make sense? Do we see that? Okay, so those two functions are inverses of each other. All right, let's take a step and look at what we have here. I'm going to go ahead and, well, we'll leave this for now. So the vertical line test to determine whether a relation is a function leads to a horizontal line test to determine whether the inverse of a relation is a function. Okay, so just because we have an equation, whenever we go to graph it, we see that it's a function, doesn't mean that its inverse will be. But I also don't test the inverse using the vertical line test. I test the inverse function using the horizontal line test. Now the rule is still the same. We test it the same way, just with a different line. If it crosses my function more than once on the horizontal line test, then the inverse function is not a function. It's just a relation. Do you see what I'm saying? Okay. So vertical line test. A relation is a function if and only if no vertical line intersects the relation's graph in more than one point. Horizontal line test, which is used just for the inverse. A relation's inverse is a function if and only if no horizontal line intersects the relation's graph at more than one point. All right, final slide. In inverse relations, you can look at example 3 on page, let's find it. Bottom of the page, 356. Okay, it gives you an example there. The inverse relation, example 3 of your book, these are inverse functions. And the domain and range of both functions is a set of all real numbers. In some cases, an inverse is not a function, but a domain can be restricted to make it a function. So the inverse of a function is denoted as f to the negative first. Okay, to the negative first denotes inverse. So even whenever we go to start using, let's say, trig functions, and you look in your graphing calculator, you'll see like above sine, cosine, and tangent, sine to the negative first, cosine to the negative first, tangent to the negative first. And we also see the negative to the negative 1 where we can make a function that way. If you see like down here on the left-hand side, that x to the negative first function there, so we can make something to the negative first, that's making it an inverse. Okay? So formulas used in applications have variables that represent really specific quantities, such as if we're like using distance equals rate times time. Or d equals distance. It means something specific. T is for time. So when finding the inverse of a formula, it's better not to interchange the variables, not to swap time and distance. For example, if d and t are interchanged, then d comes to represent time and time comes to represent distance, and that becomes really confusing. So we don't want to interchange those variables in formulas, right? Where let's say we're working with like Celsius and Fahrenheit, right? And we want to swap those or find the inverse function. We don't actually want to swap those variables because they mean something. Okay, they're not just nameless, meaningless variables. Okay. Let's see. Okay, here we go. It's going to start off with something pretty easy. We want to find the inverse function of 627, 715, 11, 5. What's the inverse of 627? 27, 6. What's the inverse of 715? 15, 7. What's the inverse of 11, 5? All right, so my answer comes out as A, right? Okay, easy. No problem there. All right, number 2, though. Find the equation of the inverse. Basically, we're saying y equals x over 3 minus 5, right? Okay, so my first step is that I want to rewrite it. What do I rewrite it as? Okay, x equals y divided by 3 minus 5. So rule number 1 is flip the variables. Rule number 2 is solve for y. You said add 5 plus 5 plus 5. So I got x plus 5 equals y divided by 3. Multiply by 3 on both sides. How much do I multiply by 3 over here? I just multiply the x by 3. Okay, I multiply the whole thing by 3, right? So y equals, and let's see. It looks like they go with just this. They don't distribute. I wish they did. 3x plus, or sorry, y times 3x plus 5. I would accept y, if this was just in your homework, I would write y equals 3x plus 15. I don't know why they don't do that. It's a little frustrating. Okay, but if you scroll down to the bottom, do you get A for number 2? You do? All right. Okay, let's come down to this one. We want to know which equation is the inverse of y equals 1/3 x squared minus 8. Well, what's the first step? Switch. Okay, so what am I writing? Y squared minus 8. Good. So you didn't take the square with the x. Good. All right, what's next? Add 8. Okay? Add 8. So I have x plus 8 equals 1/3 y squared. Now what? Multiply by 3. Good. Okay, because I can't divide by 1/3, I multiply by the reciprocal. So that's giving me 3x plus 24 equals y squared. What's next? Square root on both sides, so y equals the square root of 3x plus 24. Is A my answer for 3? Good. All right, we're understanding this okay? Awesome. Let's see if there's anything. Okay, good. Here we want to graph 6x minus 3 using the dash line, so that's my original equation, right? The y-intercept is at -3, correct? And then it's what, going up 6 over 1? And so it looks like the dash line is the same on all of them, isn't it? So really what we're looking for is just the inverse function. So y equals 6x minus 3 becomes x equals what? Okay, what do I do next? Add 3 to both sides. X plus 3 equals 6y. Divide by 6 on both sides. Why is there so much needless sound in here? Okay. All right. X plus 3 divided by 6 becomes? Okay. Y equals 1/6 x plus 1/2. What? Yeah, they kept it with A, didn't they? Right, so they kept x plus 3 on top. So they kept it like this. I prefer this, just honestly. And so A should be your answer, where we're seeing that, you know, we should only be going up 1/2. We're going to go up 1/6. Okay, I think is better, but it still works. Okay. All right, let's see if there's anything else in here. Okay, here we go. This says, use the horizontal line test to determine whether the inverse of the relation is a function. Does this pass the horizontal line test? Yes. Okay. The inverse, this says inverse is not a function, inverse is a function, because no horizontal line passes through more than one point on the graph. Is B my answer? And it's confirmed down at the bottom. You've checked the answer key? Good. Okay. So we only use the horizontal line test when we're testing what? The inverse. We don't use it for the regular function, right? Okay, we only use it then. Okay. I feel like you guys have pretty solid understanding of this. Let's look at 10 though. Okay, find the equation of the inverse. We want to identify the domain and range of each relation. Okay? Okay, good. So you flipped. Add 10 to both sides. X plus 10 equals. Okay, now what? Okay, so we got 1/9 x plus 10/9. Okay. Square root on both sides. Okay, so we have y equals. Okay, 1/9 x plus 10 over 9. Okay, so that's my equation. We got that.
Domain and
Hmm. Let's here's what I'm going to do. Let's pull out our graphing calculators. All right, do we have them? Okay, so we got y equals, I'm going to go ahead and graph the first one. That was 9x squared minus 10. Okay, let's go ahead and graph that. It says look for the domain, which is our x values, right? Okay, so let's look and see what that looks like. Is that going to end up going on and on forever, left and right? Okay, so the domain is all real numbers there, correct? Okay, all right. Let's go ahead and plug in our second one. So I'm going to start off with the square root. Okay, 1 divided by 9x. Okay, actually, I'm going to go ahead and 1 divided by 9x. So it's not just 1 divided by 9x. You know what I mean? Where 9x is on the bottom. Okay, plus 10 divided by 9. I'm going to go ahead and put that in parentheses as well. Close everything up and graph it. All right, so mine looks a little funky. I don't even, I think what it should be doing is looking something like this. I don't know if yours does a better job than mine does. It just looks like that? Okay. So what to me it almost looks like is that the domain is going to start right in here. So I don't know what that, let's see, -1, 2, 3, 4, 5, 6, 7, 8. I'd almost say -9. You know, so the x is greater than or equal to -9. So what I'm going to do is I'm going to go to y equals. I'm going to clear this first one. I'm going to hit second graph. Okay, it looks like to me that x is greater than or equal to -10 because notice y equals 0 at that point. Okay, so if I come down here to my answer for this, what was this, our last question? 10? Okay, so we got the correct one there. The domain, what we had for the first one is x is any real numbers. Okay, I didn't realize to ask for the range, but the range was going to be y is greater than or equal to -10 because it dropped down and went up from there, right? Okay, on here, all right, our domain is x is greater than or equal to -10, and our range is any real number. Yeah, yeah, they're flipped from each other, right? Which is kind of what we would see. Okay, the domain and range are reciprocals of each other. Okay? We feel like we've got this? Okay, we'll stop right there.